Okay, these are the notes on perpendicular bisectors. Perpendicular bisector theorem states, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. So in that description, if point C lies on line CD, which is part of the perpendicular bisector here, point C is equidistant from A, the end of the segment, as it is from B at the other end of the segment. So if CD is perpendicular to AB and AD is congruent to DB, these two segments are congruent, then line CA is congruent to line CB. Converse of the perpendicular bisector theorem, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So for example here, again the line CD going through AB, if CA is congruent to CB, then C lies on the bisector. So if AC is congruent to CB, then line CD is perpendicular to AB and AD, the segment here, is congruent to DB. We're going to use those two theorems to find the missing sides or finding x, the value of x down below. First example. This example looks just like the perpendicular bisector theorem example above. So we have a perpendicular line to a segment. We know it's perpendicular by the 90-degree mark, and we know that these two segments are congruent. So we further know that these segments are congruent. So we can set the two equations equal to each other. Okay, now we can solve for x. Subtract 7x on both sides. Add 48 on both sides. (6x) equals 72 divided by 6 divided by 6. Value of x is 12. Example number 2. This looks just like the converse perpendicular bisector theorem, where we're told where these two long legs are congruent to each other. So we then know that this is a perpendicular bisector, and it being a perpendicular bisector, these two segments will be congruent to each other. So we can set these two equations equal to each other. 17x minus 3 equals 9x plus 13. And we can solve for x. Nine x's cancel. 8x equals 16. 8 divided by 8. X equals 2. So now we're going to find a side, RS. This is the same perpendicular bisector theorem. We have a perpendicular bisector. Point R lies on perpendicular bisector, making these two segments congruent. So we set them equal to each other and solve for x. So we find that the value of x is 9. We're going to use this value to find what RS is, plugging 9 in for x. Four times 9 is 36. 36 plus 5 is 41. So RS equals 41. Example 4. Again, converse of the perpendicular bisector theorem. We're told that these two legs are congruent, or the hypotenuses. So we know that this is going to be perpendicular bisector, creating two equal segments on this line. So 2x plus 11 is also going to be equal to 14x minus 37. Subtract 2x, add 37. X is 48 by 12. X equals 4. Now that I know the value of x, I can plug that in and solve for the length of EG. So 2 times 4 plus 11. I'm looking for this length. X is 4, so I plug 4 in for x. Get 8 plus 11. So EG equals 19. Solving for AB, that's the full side. So this is back to the converse perpendicular bisector theorem, just like the one we did before. So I know that AD will be equal to DB because this is a perpendicular bisector, because these two sides are congruent. So I could set these two equations equal to each other. 5x minus 11 equals 3x plus 17. Solve for x. It's 28 divided by 2. X equals 14. So I'm going to plug that in for both of these segments and add the segments together. Five times 14 is 70. 70 minus 11 is 59. So that's one segment. Solve for the next segment. 3 times 14, 42, plus 17, 59. They are both 59, so we know we did that correctly. Add the two together. Okay, to get 118. 118 is the length of AB. Now you don't have to solve it the second time, but it is good to solve it to make sure that you did it correctly. If I got two different numbers, then I know I did it wrong. Alright, so I want to find the length of JK. I have a perpendicular bisector. I know that these segments will be set equal to each other. So 6x minus 26 equals 3x plus 34. Okay, next you will solve for x. Once you find the value of x, plug that in to find the length of JK.